Welcome to the audiovisual presentation of a global industrial leader in the production of seamless pipes used primarily in the area of extraction and transportation of oil and natural gas. We are talking about KSP, an acronym for Kazakhstan Seamless Pipe, located in Pavlodar in northeastern Kazakhstan, only 100 kilometers from the Russian border. The product's commercial designation can be summarized by the OCTG, Oil Country Tubular Goods, as well as line pipe. KSP controls the entire pipe production cycle, from scrap, which feeds the electric arc furnace of the steel mill, to the rolling mill and successive operations to obtain a finished product which meets the specifications requested by the customer. This integrated industrial structure, supported by a quality management system, guarantees the delivery to the customers of products of a consistent and proper quality. The equipment, inclusive of those for the finishing lines, have been engineered to produce pipes that comply with the applicable API and GO standards. The audiovisual documentation that we will see illustrates in a summarized manner the principal steps in KSP's production process, emphasizing all the characteristics that allow KSP's products to achieve an absolute guarantee of quality. The pipe manufacturing process includes the following steps: the hot rolling line that cuts, heats, pierces, and rolls the bars, thus obtaining a pipe having the desired length and wall thickness. Subsequently, the pipe is heat treated, if necessary, or goes straight through the quality assurance and finishing lines. After having completed all the necessary activities, the pipes are ready for shipment. We will begin our tour from the first production area where the process begins. The goal of the hot rolling line is to transform, starting from a temperature around 1,280 degrees Celsius, a billet or a bloom into a hollow entity, the pipe, with specific dimensions as defined by the API, GOST, ASTM, etc. manufacturing specifications, or which are directly requested by the customer. The production range for diameters is 2 3/8 inches to 10 3/4 inches, that is 60.3 to 273 millimeters, whereas the range in wall thickness is between 3.9 to 40 millimeters. The maximum diameter can be increased up to 13 5/8 inches with the purchase of the appropriate tools, since the key machines have already been engineered taking this into consideration. The line is made up of the following 7 sections. A. The bar cutting area for the preparation of the billets with the right weight for the subsequent furnace feeding. B. The rotary hearth furnace, whose function is that of heating material placed in the furnace at a specific temperature in the most homogeneous possible manner. C. The cross-rolling mill that transforms the billet into a hollow with a heavy wall thickness. D. The retained mandrel mill with 6 stands, the true heart of the plant, along with the extracting mill with 3 stands, has the function of transforming the hollow generated by the CRM into a pipe characterized by a relatively thin wall with respect to the hollow, as well as a length up to 28 meters. Given the vast range of sizes to be produced, the total work to be done to obtain the final dimensions is divided between 2 machines. The adopted criteria allows the achievement of greater production efficiency, while at the same time it limits the use of tools. Consequently, the RMM is equipped to roll 2 sizes. The diameter is 191 millimeters and 288 millimeters in dimensions adequate for obtaining the desired finished products passing through the stretch-reducing mill, that is, the SRM. E. The reheating furnace mainly has the function of equalizing the temperature to roughly 880 degrees Celsius of the shell before moving to the SRM. The other important function is that of having the capability to perform, along with the variable speed feeding table, the inline normalization, allowing for more homogeneous microstructure, something always more requested for casing and line pipe products in any grade of steel without the necessity of offline heat treatment. F. The stretch-reducing mill has the function of reducing both the diameter, the wall thickness, and the pipes produced at the RMM to the required dimensions foreseen in the production range. In the reduction operation, the calibration of the external diameter of the pipe also takes place, guaranteeing a precision in the measurement of the diameter which is lesser or equal to 0.3% of the diameter with an absolute minimum value of 0.3 millimeters. The mill is composed of 24 stands, each one with 3 rolls. The last 3 stands with the round calibration have adjustable rolls allowing for small diameter adjustments in a range of approximately 1.5 millimeters to hit the tolerance range on the external diameter in relation to other possible tolerances as per different specification, nominal diameters being equal, or to prepare the pipe for subsequent processing, such as thermal treatment, for example. G. The cooling bed and the layer cutting system are dedicated to cool the pipes just produced and to cut them to the required length. The cutting system also cuts the ends of the pipes with thicker wall than the nominal caused by the reduction made at the SRM. The material to be rolled is generally a billet obtained from bars from continuous casting. The limits given to the steel producer are sufficiently restrictive to guarantee, number 1, from a geometric point of view, rolling without problems, including those related to the yield. And number 2, from the perspective of structure, chemical composition, and level of inclusions, the achievement of the requested characteristics of the finished product. Having a steel mill dedicated to the supply of the hot rolling mill under one sole responsibility, as in the case of KSP, is the basis for achieving and maintaining a constant level of quality in the product over time. The billets of 2 different diameters as a function of the dimensions to roll in the RMM and with weights defined specifically according to the product that must be obtained are heated in the RHF at a temperature of approximately 1,280 degrees Celsius, following a heating curve that guarantees a temperature variation in the billet of more or less than 15 degrees Celsius, always maintaining the requested productivity of the hot rolling mill. The RHF has been designed for an hourly production of 110 tons per hour. The bars arrive in the hot rolling mill's storage already in lengths, which are multiples of the billets to be placed in the furnace and are stored by heat and length in single racks in such a way to avoid any possible mix-ups. If the operations at the steel mill have been carried out according to the request, that is, with the guarantee that every billet shall have the prescribed weight within a specific tolerance, the cut is executed as per the program. Otherwise, the cutting rules themselves are automatically changed in line using the weight and length measured at the beginning of the process on each bar. In the area from the entry table of the cutting line of the bars to the inlet table of the furnace, the product lot tracking begins. This is managed from the automation of level 2, and formally the beginning takes place with the weighing of the single billet before being placed in the furnace. From this moment on, the lot identifier that always indicates the heat number and the hot rolling order associated with the customer will not change for the entire production process until the finished tube is obtained. To avoid possible mix-up errors, if the control is based solely on automatic tracking, a step is skipped in the loading of different lots. The weighing of the billet, besides the control, is necessary for yield calculation of the material used during the entire process, both for the HRL as well as for the finishing line. Along the entire hot rolling line, different control systems are installed, both for monitoring the machine as well as for measuring the diameter and wall thickness of the shell and of the finished pipe. This system, based upon a laser technique, is very important since other than providing the dimensions still in hot rolling, it allows to obtain an automatic regulation as for the well-defined rules of SRM. The setup of the main machines in the process, CRM, RMM, and SRM, is carried out automatically based upon models that, upon changing the dimensions to be rolled based upon a table or with direct recalculation, supply the new working parameters. A key factor for the correct management of the production is the marking of the lot code on each pipe. The marking is carried out on pipes of each layer after cuts have been made on the ends as well as on intermediate ones. The lot code is automatically generated and is associated with the combination of the heat number and the hot rolling order number that is launched in production. At the end of the line, once pipes have been cut and are almost at ambient temperature, a percentage of pipes are inspected with a non-destructive testing machine in line with the hot rolling mill, with the only purpose of verifying the entire process in such a way as to have, as soon as possible, an indication of possible defects that pipes in production may have. In such a way, decisions can be taken regarding upcoming actions in the following phases and to provide the steel mill with feedback. In any event, all possible repairs are carried out in the dedicated lines of quality assurance outside of the production pressure of the hot rolling mill. After all the previous activities, the pipes, now at ambient temperature, are discharged in the appropriate unloading cradles of the line, collected in bundles identified by a label with the lot identification data, and stored in storage number 1 or number 1A South while waiting for the start of the operations to be carried out by the finishing lines. The two heat treatment lines have the aim of giving the pipes the structural and physical characteristics demanded by the standards or by supply specification. The process consists of a sequence of controlled heating and cooling, which allows improving both the microstructure of the steel matrix and the mechanical properties, starting from steel with chemical compositions relatively poor of alloys. The heat treatment capacity of the two lines is 150,000 tons a year. With the same aim of improving the structure of the material of the pipe, the hot rolling line is designed so as to complete the normalization inline for all the rolled products. The two lines differ for the dimensional range in which they are able to operate. The equipment is of the same typology with the exception of the quenching system on the K2 line. The two lines have enough overlap to be able to solve possible productivity problems with one of the two, or to face possible variations of dimensional range requested by the client. On the K2 line, which produces the bigger pipes, both in diameter and in thickness, the quenching system is made up of water cooling tunnel, tangentially operating on the external surface of the pipe, as in the case of the smaller line, and for dimensions larger than 7 inches, a cooling system of the internal surface. The internal cooling is done contemporarily with the external cooling, with injection of pressurized water released from nozzles positioned on the head of the lance inserted in the pipe, so as not to damage the internal of the furnace or the quenching itself. The adoption of this engineering solution is aimed to guarantee the highest percentage of austenite martensite transformation, even in thicker pipes, which is essential to obtain the consistent mechanical and structural characteristics required along every pipe and from one pipe to the other. The operation begins with the loading of the pipes on the inlet table of the line to be fed into the high-temperature furnace, about 900 degrees centigrade. Once the quench and tempering is done, respecting the parameters of temperature and length of time in the furnaces necessary for the specific grade of the steel to be obtained, on the external surface of every pipe, the hardness is measured by an automatic device installed on the line. As the hardness is directly connected to the tensile strength of the material, this is one of the first checks which indicate the correctness of the operation of the plant. With the aim of a complete measurement of all the parameters, at least a sample of pipe per lot is cut in a dedicated station and, with all its labeling, sent to the laboratory for necessary tests. The gathering in the unloading cradle and the storing lot by lot in storage bay number 5 for K1 and storage number 1 for K2 conclude the operation. The product continues to flow in the two quality assurance lines that have the purpose of checking that the pipes in production meet the technical specifications that have been requested in terms of straightness, internal and external surface defects, dimension tolerance, steel grade, and internal resistance to pressure. The pipes to be processed can be as rolled, quench and tempered, normalized, upset, and heat treated. The two lines are differentiated by the dimensional range in which they can operate. The equipment is, on the contrary, of the same typology. The two lines have a sufficient overlap to satisfy any possible failures of one of the two lines or to deal with possible variations of the dimensional mix requested by customers. In the engineering phase, particular care was given to the flow of pipes in production. The aim is that to assure the traceability of the product both in terms of the lot as well as, when requested, of the single pipe. Level 2 of the line management of this line, like all the others, can show on the operator workstation screen the position of every pipe being produced, from the inlet table to the cradles at the end of the line. The processing begins with the positioning of a bundle of pipes on the line inlet table and the first operating machine, the pipe straightener. To be honest, from this point of view, the line is sufficiently flexible in that it is possible to carry out partial work cycles without going through all the machines that, in the specific case, do not perform operations on the pipe. This is the case for pipes that have previously already been straightened or on those in which only a hydraulic test is required. All the pipes that, per bundle, are placed on the inlet table are each identified with a lot number. Therefore, it is relatively easy and unequivocal to avoid any mix-ups between lots and different products right from the beginning of the cycle. The tracking installed for the management of the lines has a function that notifies an operator in the sector line if there are still pipes present with a lot number different from that identifying the lot that is ready to enter the line to be processed. The key machine in the pipe examination process in the quality assurance lines are the non-destructive testing NDT machines. To ensure that the examination takes place in the best conditions, both to avoid damaging the machines as well as false defective warnings, every pipe is cleaned at the ends from the burr by manual grinding and internally cleaned to remove the residual scale by blowing compressed air. The station is equipped with a dust collection system. The NDT is made up of 4 different units, plus other surfaces, allowing the detection along the entire pipe of possible longitudinal, transversal, internal, and external defects, as well as the measurement of the wall thickness according to 4 generatrix and the possible steel grade variation. Every time nonconformity is detected with respect to the predefined calibration level, the machine itself indicates the area of the possible defect. A combination of colors shows the nature of the defect. To avoid that, the spraying system malfunctions by making a pipe appear to be free from defects only visually because the electronic path is in any event registered and saved. The spraying system is automatically tested when every new pipe enters the machine, leaving a trace on the front end of the pipe itself. It is always possible to reconnect the saved path with the specific pipe that passed through NDT. The pipes without defective warnings are automatically sent to the hydraulic testing machine. The others are, upon the request of an operator, sent to one of the repair stations, 3 for line C1 and 4 for line C2. According to the type of defect, repairs are carried out with a manual grinder, respecting the guidelines of the applicable specifications. Every repair is followed by a punctual recheck to verify that the pipe is still in acceptable conditions compared to the applicable requirements. In case the repairs are impossible only on a part of the pipe, the damaged part is cut. If the remaining length is without defects and is within the acceptable range, the pipe is sent to a hydraulic testing machine. Otherwise, it is disposed of for non-repairable defects. The tracking system keeps this in memory. After the hydraulic test, all pipes are individually identified by marking them in the appropriate station with the lot number clearly shown, in such a way that there is no margin for errors in the operations that will be carried out in the successive finishing lines. The line has the aim to perform other inspections compared to those already carried out on the quality assurance line required or by the production standards or specifically by the client. The key machine of the line, together with the highly specialized operator that runs it, is the ultrasonic testing machine. It is made up of a strong metal gantry structure longer than the maximum length of the pipe that is produced by the rolling mill. On the beam runs lengthwise the probe trolley with all the necessary equipment to carry out the inspections. The unit itself incorporates a pipe rotating system. Combining the linear movement of the probe with the rotation of the pipe to be inspected, 100% inspection of the body of the same pipe can be obtained. During the check are detected, based on a prefix setting, longitudinal and traversal defects of the internal and external surface, inside the wall thickness and others possible out of tolerance wall thickness not found in the previous checks. The double level of the inspections performed, EMI, electromagnetic inspection on the line of quality assurance, and UT, that is ultrasonic testing on this line, is the best way to guarantee the production of pipes without defects. The capability of the line ranges from 2 3/8 inches to 13 5/8 inches. It has a nominal production capacity of 90,000 tons a year, and it can process every type of product as long as it is straight enough and the ends are without fins or residual cuttings. This plant also doesn't check the beginning and ends of each pipe about 100 millimeters, and for this reason, on the threading and beveling line ends, electromagnetic inspection devices have been installed. As previously said, normally the inspection of this machine are carried out after the pipes have been already checked into the quality assurance line and before they are sent to the threading or beveling lines. The process flow on the line is very simple. Loading of the pipes on the inlet table, checks with the ultrasonic machine, possible cutting or repair of defective parts, reloading in the ultrasonic machine to verify the complete removal of the defect, and unloading from the line. Also on this line, on which the Level 2 management system is installed, all the plant engineering and procedural precautions are used to avoid the risk of mix-up and to guarantee the traceability, at least by lot, minimum requirement for the products for which these controls are demanded. Let's go now to see which are the following processes the pipe undergoes. One is the threading of the ends of the pipe. The product enters the threading lines that have the function of threading the two ends of the pipe to screw the coupling to one of the two ends in such a way that once all the other necessary operations have been carried out, the pipe has all the features corresponding to the technical specifications or to the specific requests of the customer. The two threading lines are different in relation to the dimensional range in which they can operate. The equipment, on the other hand, is of the same type. The two lines have a sufficient overlap to satisfy any possible failures of one of the two lines or to deal with possible variations of the dimensional mix requested by customers. To assure the traceability of the product for these lines, all the criteria and construction and management solutions are applied as done for the quality assurance lines. The processing begins with the positioning of a bundle of pipes on the inlet table of the line to send to the first of the two machines for the threading of the corresponding end. All the pipes that, per bundle, are positioned on the inlet table are already identified with the lot number stenciled at the end of the quality assurance operation. During the processing to be carried out in order to obtain the finished product, the movement of the pipe from a workstation to another always occurs transversely with respect to the axis of the pipe to avoid any possible damage of the thread once this has been done. Only after the application of the dedicated protectors, the pipe moves in a longitudinal manner. The key machines in the process are the two CNC computerized numerical control threading machines with 5 axes, with a high productivity and suitable for threading API joints or similar, premium joints with mechanical seal with coupling or integral. Each threading machine is aimed to thread one of the two ends of the pipe. They are positioned optimally along the line. Each of them is the reference point of an autonomous island in which, after the thread has been done, checkups are carried out, both visual and geometrical ones, with the help of appropriate gauges and electromagnetic ones, that is MPI. In the event of a defect, the pipe does not move on to the subsequent operation, but is conveyed via rollers and chains in the appropriate area designated for cutting the defective thread and bringing it back in the same manner to the loading table of the threading machine. There are no offline operations or handling to be carried out with overhead cranes. This also contributes to the decrease of possible mix-ups. The screwing of the coupling according to the applicable specifications is preceded by the application of grease, thread compound, in the threaded area. The next passage of the mandrel of a calibrated diameter and function of the product being processed is the final operation before the second threading that is carried out in the same manner as previously described, including the related inspections. Before the application of the pipe's thread protections, the second end can be treated with a phosphate primer solution with zinc in order to protect the threaded area, on which also grease and protectors are applied. In the weighing, measuring, stenciling, and/or marking area, data pertaining to specifications as well as all indications are written on each pipe, coherent with the original lot, specifications or customer requests for which the pipes are manufactured. An important output of this workstation is also the packing list, which is one of the primary documents to deliver the pipes to the customer. The final packing requires the temporary protection with water-based paint, dried in an oven, and, for pipes, up to 6 5/8 inches produced on line C5. The fastening in hexagonal bundles. For larger diameters, the pipes are unloaded in non-fastened bundles and placed in warehouse racks ready for shipment. The bundles, both the hexagonal as well as the other ones, in any case are identified with a label which indicates the heat number, the dimensions, the type of the product, and all data pertaining to the customer. This is a line where all the operations, beveling of the ends included, of the pipes employed for the transport of fluids are done. Commonly, these pipes are produced according to the standards API, ASTM, GOST. Generally, the connection of these pipes is made by welding. For this reason, the ends must be shaped in order to prepare them to receive the filler metal of the welding. According to the specific purpose of the pipe's length of up to about 6 meters can be required. For this reason, there is, in the line, a cutting station in which the pipes produced in double length, in order to better exploit the production capacity of the hot rolling and quality assurance lines, can be, if required, divided in 2 parts. In the design of this line, too, the material flow was studied very carefully to assure the traceability of each production lot, or, when required, of each pipe. From a plant engineering point of view, in order to avoid mix-up, an area recycling system has been created, specific for the line, that brings back to the beveling station the pipes in which defects have been found at the ends by the MPI inspection. The operations begin leaving a bundle of pipes on the inlet table of the line after each pipe is sent to the first of 2 FASIG and beveling machines. The machines are set up in battery, which means that as soon as the first bevel is complete, the pipe is sent to the second machine to process the other end. In the case that the pipe needs to be cut in half before to be beveled, it goes through the saw, and the 2 halves follow the cycle described above. Before passing on to the weighing, measuring, and stenciling stamping stations, the pipe goes through, as said before, an electromagnetic control of the ends, NPI. The recycling system allows the possible repair of defective bevel without offline operations. The unloading section of the line has the same functions and follows the same plant structure already described for the threading line. What you have seen are the concrete reasons which make KSP products absolutely safe. And for this reason, choosing KSP as your partner means making a choice of total safety.